So far, we have finished configuring HFC and PSTN clouds. We have configured IP addresses on routers, PCs, and servers. We have also configured all the necessary DHCP servers and clients. And now we're going to go and configure NAT. So we have dynamic NAT first on HFC home and DSL home routers, and then static NAT on router 7. So let's start with HFC home. Here we want to translate all of the private IP addresses into this one public IP address, and we're going to do that using a standard access list. So I'm going to create that access list, standard 1. Permit 192.168.1.0.0.0.255, and then use the IPNAT command. It's going to be inside source list 1, and then translate that into interface gigabit Ethernet 0/0's IP address. And then I'm going to use this overload word, which means that we will be translating many private IP addresses into several public IP addresses, in this case only one public IP address. Don't forget to tell the interfaces that they should be doing NAT, and also where do they belong, meaning which NAT side. Gigabit Ethernet 0/1 is inside, so I'm going to say IPNAT inside, and interface Gigabit Ethernet 0/0 is on the outside. That's for HFC home. We should do the exact same thing on DSL home. Enable configure terminal, IP access list standard 1, permit 192.168.1.0.0.0.255, and then IPNAT inside source list 1 to interface Gigabit Ethernet 0/0. Let me just make sure that I got the right interface, and then overload. Interface Gigabit Ethernet 0/0 is outside, and interface Gigabit Ethernet 0/1 is inside. And that's for dynamic NAT. We are next required to configure static NAT on router 7, with both 10.0.1 and 10.0.2 being translated to 20.0.0 something. So let's do that. Enable configure terminal, and we start with the NAT commands right away. IPNAT inside source static. We're translating 10.0.1.1 into 20.0.0.3. That's the first available IP address. We used 1 and 2 on router interfaces right here, so we will use 20.0.0.3, and then we'll use 20.0.0.4 for the web server. I'm going to add a label here to make sure we remember that IP address, because we will be needing it while testing. So 20.0.0.6 is going to be allocated to this server right here. 20.0.0.5 is going to be the gateway for the second LAN. And then 20.0.0.6 is going to be used for 10.0.2.2. Don't forget to tell the interfaces what they're supposed to do. So interface Gigabit Ethernet 0/1 is IPNAT outside. And then interface Gigabit Ethernet 0/0 is IPNAT inside. And this time we have another inside interface, interface Gigabit Ethernet 0/2. That's this interface right here. We're also going to say IPNAT inside. That's it for static NAT. Our next task is to configure routing. First autonomous system to configure is 2500 OSPF plus route propagation. Let me explain real quick what route propagation is. So once this is all configured, when we look at the routing table of router 2 will know exactly where each of these subnets is located in this entire topology. So 31, 32, 33, but then also 20, 7.3, 99.0, 248, etc., etc. So it will know where all of these IP addresses are, and once it receives a packet with a destination IP address that belongs to any of these subnets, it will know what to do with that packet. This router, this router, this router, this router, however, will not know what to do with those packets because they don't have the BGP routing table. They will only have their local autonomous system routing table. So these routers will have the OSPF routing table. They will only be aware of this network and this network and this network, and that's it. We want to make sure they know what to do with packets with a destination IP address of any other network. That's why we will give them a default route. Now in this scenario right here, we only have 2 routers, and it would actually be relatively easy to configure, let's say, up to 10 routers with a default route manually, but we don't want to do that in case you have hundreds of routers, which is totally possible to happen in an autonomous system. You want to use this route propagation option, and what it does is you will configure one router with a default route. In this case, that's going to be router 2, and we're going to give it a default route which will send all the traffic to this interface right here, and then we're going to propagate that default route. What that means is this router will, through OSPF, tell the other routers inside OSPF network that it has a default route. So that means that these routers will have an additional route in their routing table, which will be a default route, but you will see it's going to be a bit different. So let's start with OSPF here. I'm going to start from router 3. Start the OSPF process and then advertise the directly connected network. So this is going to be 007 since it's /29, and they're all going to be in area 0. And then we have network 32.0.0.0.0.0.255 area 0. And then on router 4, we will have 33.0.0.0.0.0.255 area 0, and then network 31.0.0.0.0.0.7 area 0. Now on to router 2. We want to create this default route first. Enable configure terminal, IP route, all zeros, and then exit interface serial 000, router OSPF 1, advertise the only OSPF network connected to this router, that's 31.0.0.0.0.0.7 area 0, and then the route propagation command is default information originate, and then we're getting these messages that neighborships have been established with these 2 routers. And now I'm going to check what the routing table looks like on router 3, do show IP route. And we can see this propagated default route here in the end. So these 2 are the directly connected networks, and then we have this remote network which was learned through OSPF, and then we have this default route which was also learned through OSPF. What this route tells this router is if you get a packet whose destination IP doesn't belong to any of these subnets in the existing routes in the routing table, use the default route, because this router that advertised this default route will know what to do with those packets. For this autonomous system right here, we are asked to configure static routing. That will actually be fairly simple because this router will only need a default route toward a router 6. And that's because this router is really not aware of the existence of these private networks right here. So we will not be configuring anything on this router. Let's go to router 7. IP route, default route. And then again, let's use the exit interface, gigabit Ethernet 0/1. We always get this warning because it's better to use the next hop IP address, but not always really. So in this case, for example, where this router is getting the IP address from DHCP, you will not know the IP address always. So it might change. It might not be a static IP. So in that case, it's better to use the interface. Okay, on to EIGRP now. We can't use route propagation here because it's not supported in Packet Tracer, so you can only use it for RIP and OSPF. So we will be using default routes. Luckily, we only have 2 routers, so let's start with a router HFC home, router EIGRP, and then for autonomous system number, I will use the same autonomous system number we will be using for BGP 2100, and then say no auto summary, and then advertise this one network that we have connected to this router that needs to be advertised in the routing protocols. Again, this network behind NAT, there's no need to advertise that. So that's network 183.200.000.255. And that's it. Now I want to configure this default route. And let's use the IP address this time, 183.201. As you can see, no warnings here. Let me just check that that is the IP we configured. Yes, it is. Okay, 183.201. On to HFC network router now. We will need a default route here as well, so let's configure that first. IP route 0000, exit interface gigabit Ethernet 0/1, router EIGRP 2100, no auto summary, network 183.200.000.255, and then network 13.0.81.000.255. Now let's move on to this other OSPF autonomous system. We're going to start from DSL home. Enable configure terminal router OSPF1. We will not be configuring the default route on these 2 routers actually, let's configure the default route on this router and then propagate. The bad thing about that is that this default route will also be propagated to this router right here, and you could possibly have a loop here if OSPF fails, but as long as OSPF is working, it's going to be okay because the default route is the last resort. So a router will send a packet to any of the routes that it matches before it hits the default route. So default route is for those packets that you don't really know what to do with. And router 5 will of course be a BGP router. It will know all the routes in the entire topology, and therefore there's no reason for it to use the default route. Okay, configuring OSPF on DSL home. We should only advertise this public network 99.0.248.0.0.0.255 area 0. And that's it for DSL home. DSL network, let's create that default route, IP route 000.0.0.0, And then I'm going to use the next hop IP address, 7301. At least I hope that's what we configured. Yes, we have. If you were to use 7302, the router would actually give you a warning that you're using the IP address that is configured on this router, because this is meant for next hop IP address. Okay, router OSPF1 advertising 99.0.248.0.0.0.255 area 0. We will get that message that a neighborship has been established. Let's wait for that. There it is. And then we'll advertise 730.0.0.0.0.3 area 0. Oh, and then I also want to use this default information originate command to propagate this default route. And then on router 5, I'm going to say enable configure terminal router OSPF1 network 730.0.0.0.0.3 area 0. And that's it for the OSPF network. Our next task is BGP and then redistribution and then access lists. So I'm going to cut the video here because it's already long enough, and then I will provide in the next lesson this packet tracer file where we have configured all of these things. So we have finished the first 6 tasks. Pretty good, if you ask me. So see you in the next lesson where we will continue with the configuration.